And then maths is next Wednesday now. When's the next maths is June 12th. What day is June 12th? Wednesday. So, oh wait, what? So no, stats and mechanics is Friday. So it's Wednesday and Friday. On Thursday I have a morning exam, which is fine. So next Thursday we'll do whatever. I just need to do like proper hard questions because.
For pure, is it?
Yeah.
Okay.
Next again, it's just exam questions, I guess.
So this is the last question that was on last year's paper. Are you familiar with it?
As in, have I done it? No.
Yeah. Okay, we'll do this. So this is find the area of that thing. And we do this, and that's its equation.
Right, my first paper looked nothing like that.
For
Maths is pure.
you're doing year 2?
Yeah.
This is it.
Is that year 2?
Yep.
Well, that's my last.
So year one is like easy peasy stuff.
No, it's like 2 pure papers. So pure 1 and pure 2. No, it's not actually that. It's paper 1 and paper 2, and they're both exactly the same. They're just 2 different pure papers. And like it was bare hard. Like it was. I can't even tell you what it was. There's like a bunch of integration. Okay, there's like an integration thing, but they didn't give you the limits.
Right.
Of one side.
Mm-hmm.
But if you put that in the calculator, it'd give you obviously the roots and stuff. But then you weren't allowed to use those roots, and it was really confusing. I can't find my pen. Okay. Y equals 32. It's 2x minus 2 plus 3x minus 8. Point lies in 4, 6. 9 is L is normal to see at the point. The region R is shaded by a line with equation x equals 2. To the lower limit is x equals 2. That's the curve. So we need to work out the equation of L.
Mm-hmm.
So L intersects P. No, C, sorry. P, wait, what's P? Yeah, P is the intersection of. Okay. I don't know where to start. I feel like I should differentiate.
Yep.
And that will give me the gradient of line L. No, that wouldn't. That's curved.
So after you differentiate, what will you do?
Negative reciprocal it.
Well, when you differentiate this, you'll get. Okay, go on.
I'm just going to differentiate because I don't know what else to do. Minus 2 times 32 is.
That's what I was checking. After you get the dy dx, and it's a bunch of x's, what will you do with that to get the gradient, to get m?
Put 2 into it? Or 4?
Yes, you'll sub 4 in.
Yeah.
Okay, great. Calculator magic.
So minus 16x minus 1 plus 3.
And you said you'll sub in when x is 4. And so gradient is,
What do you get?
I got 2.
What? How do you differentiate?
Do you have that on your fancy calculator?
No.
You must somewhere. Let's take a look.
Oh, hang on. Option. Except math. DDX. Oh, I do have that. Oh, wait, hang on. And x equals 4. Yeah. That gives us 2. So the gradient is 2. So the gradient of the normal would be minus a half.
Yep.
And then we know that it goes, L goes through the point 46. So you can work out the equation for L.
Mm-hmm.
Y minus 6 equals minus a half. X minus 4, 2y minus 12 equals minus x plus 4. 2y equals minus x plus 8. Y equals minus half x is 4. Can I check? 4 plus 12 is 16. 16 divided by 2 is 8. So y equals minus a half x plus 8. If you put that in the calculator, it probably work out in my head, but the root of that is not found.
So what do you... What are you messing around with there?
Found the equation of y equals minus half x plus 8.
Right.
So that's the equation of L.
Okay.
Isn't it? And when I put that in the calculator, it's not giving me a root.
I don't know what that means. What are you trying to find?
Where it crosses the x-axis.
And where it crosses the x-axis, what do you know about that point?
That's when y equals 0.
Okay, so 0 minus 6 alpha equals minus a half.
So the integrals are 2 and 16. You got 29. Oh, 16.
So that's 16.
And then so what am I integrating? Let's see.
Yep. Between where and where?
2 and 16.
Why is that?
Because that's just that. Yeah.
So wouldn't that give you the area under the curve? And Yeah, all the way up to 16, so like that entire area all there.
Yeah.
What if you split it like that?
I don't know what that point is. Oh, 4.
Yeah.
So it's 2 to 4. And then just do half the base times height of that.
Okay.
Of the triangle. When you do an integral, is a bigger number at the top?
Yeah.
Yeah. Good question. So 32x minus 2 plus 3x minus 8. That integrates to. You can't just use a calculator.
Yeah.
You have to show.
I'll just write down what I put into the calculator.
So 32x minus 2, you increase it by 1, so you get 32x minus 1 over minus 1.
And so
Plus
you said a half times base times height.
Minus 8x for 2. So 4. And then you put that in, so you get something times calculator. (32 over x squared plus 3x minus 8. Or 2 equals 10. With 10 plus 12 times 6. Oh wait, no, it's half the base, so 6 times 6 is 36. The 10 plus 36 equals 4.
I just want to see what the mark scheme. So I see 14. Where's 15? Am I looking at the wrong year? This was question
Paper 1.
15. So that's paper 1. So what's this one?
That's paper 1.
What paper did I open?
That was the May. So I feel like that's like a mock, or I think that's AS.
Is this AS? I think I accidentally pressed the AS one.
Yeah, I was gonna say because the last question is just too easy.
Ah, okay. Sorry. That was AS, I think. Alright, last question from this one. Okay, let's do this.
I think we've done it.
Oh, yeah. So,
Should be the quotient rule.
yep.
So u equals 4 sine 2x. V, is it dv over dx that equals?
Say it again, sorry?
Quotient rule, does v equal e to the root 2x minus 1?
U on top, V on bottom.
So u equals 4 sine 2x, v equals e root 2x minus 1 du over dx equals 4. Is it 4 times the 2?
Uh,
8 equals 2x.
that would be 8 cos 2x.
And the other one is root 2e root 2x minus 1.
Root 2e. Is that what you have on the top?
Morning.
And then yeah, you can write it. I can't want to write it. Is that the rule?
Yeah.
V times du over dx minus u times dv over dx over v squared.
Mm-hmm.
And then cancel out any 2x thing. Or does it have to be in every term for you to cancel out? It is in every term. Oh no.
It is.
Oh yeah, cancel out. So you're left with 8 cos 2x minus 4 sine 2x times root 2.
Yeah. Over.
Over that, but just without squared.
Yeah.
So the root 2 times the 4. Or shall we leave it? I don't know. I'm just gonna go. So 8 cos 2x minus 4 root 2 sine 2x over what's it called? E root 2x minus 1. Don't know what to do.
How do you find turning points for a curve? What do you know about them?
I don't know.
Gradient?
Is there?
Yeah.
Gradient equals 0. Oh, so that is equal to 0.
Yeah.
So that equals equal to 0, and then times the e root 2x minus 1, which gets just equals 0.
Mm-hmm.
So 8 cos 2x minus 4 root 2 sine 2x equals 0. Then 8 cos 2x equals 4 root 2 sine x. Then we're trying to get tan. Yeah. And then divide that. No, hang on. Oh, I've messed up somewhere. How are you? So 4 root 2 over.
You haven't messed up. What you divide by?
Divide by 8.
No.
Well, I want to divide by cos to get the tan, but then what do you do with the. Wait, hang on.
They don't both have 8 in common.
Oh. So divide by cos 2x.
What else did he have in common?
I don't know, root 2. Oh, do you want to change that into root 2?
Do they both have root 2 in common?
Well, 8 if you change it to 2 root 2.
What do 8 and 4 have in common?
2.
Saba. What's the biggest number?
4. 4.
So if you want to do it in one go, that'll work.
divided by 4 cos 2x minus. Hang on. 8 cos 2x equals 4 root 2 sine 2x. Divide that by 4 cos 2x and that by 4 cos gives you 2 equals root 2 tan 2x. What do you do with the 2?
We could have divided both sides. Well, you want just 1 tan 2x.
Yeah.
So how do you get 1 tan 2x?
Divided by root 2.
And put 2 over root 2 into your calculator.
Because root 2.
Boom. Okay. Using your answers.
Oh, the transformation gram.
So we have to do these transformations, the turning points of f of 2x.
So 2x means times each x by 2.
Oh.
If you go 2 is scale factor half.
It would mean you would, well, if x becomes 2x,
Scale factor, it's like in squashes.
Yeah.
No, in large squashes.
Yeah.
Scale factor half.
Yeah.
And then the other one is 3 minus 2 outside of the bracket. I know minus means reflection, but it could also mean translation.
So let's just do part 1 first.
Can I put it to calculator? No, you can't. No, you could. Okay, so all the x coordinates times by half, so divide by 2. So, into a calculator.
Why do you put it into calculator?
Just that graph.
Okay.
Or sine. Does it say anything to do with graphical and numerical methods? Because sometimes it does that.
No.
Oh, good. E root 2x minus 1. The turning point, what's that also known as? The maximum.
Maximum, minimum.
The maximum is 0.47. Oh, it's not going to help.
Is that radians?
Oh, yeah.
Oh yeah, it is radians.
Are we keeping it in radians or? No, radians is what I need. Because degree did not give me a graph. Minimum point is 2.04. So 2.05 is the minimum point. So if you're doing that by a scale factor of a half, then a turning point is 2.04. But what 8 divided by 2, 1.02. 2. I don't think this is going to be right, if I'm honest. 2.05. Yeah. And then for the maximum, it's 0.47765. So half of that is 0.24.
3 sig fig?
Which one? Turning on maximum.
For your final answer.
I don't know.
You don't know it's a 3 sig fig? So you're just halving it?
What do I have?
You just halved it a second ago. I think it was 0.47765 or something.
0.239.
Say it again. 0.
239.
Okay. And so, which one is that? The maximum then?
That was the maximum. The minimum is 1.024. Oh, 3 sig fig is 1.02.
1.02.
That number that you just had, I didn't get that 3 point whatever.
I did pi plus first answer.
What was your first answer? The 0.47?
Yeah, hang on. No. Because I need to take into account the 2x thing, don't I? So I got ahead of myself. Don't worry about that one. 1.02. Max scheme. Sample. Max scheme. This is 15. Is this the right paper? Sample paper 1 max scheme.
It's hot.
1.02 and 0.478.
That's just the 0 point.
Ah, yeah, so x equals.
They don't divide it by 2.
And attempts to find the second solution. Let me read this question. Oh, they wanted just the minimum.
Where do they get the 1.7 thing?
Part 2. You're not asked for the maximum.
Oh, it's part 2. Is that the answer for part 2?
I think it might be, yeah.
Oh, okay, no, we're fine. Wait, they didn't divide it by 2 though.
They did in the end. So you had.
Oh yeah, I got 1.02. I got 1.82.
Yeah.
And what about the other answer? Oh, which is minimum. Yeah. I'm back on track. What's the transformation for the 3 minus 2 one? Transformation.
Well, f of x, it becomes 2f of x. What's that?
Like all the y coordinates are times by 2.
Yeah.
Stretch.
Yeah. And then that becomes minus 2f of x.
Reflected in the y-axis.
The y has changed sign, and so it's reflected in the x-axis.
Yeah.
And then it is 3. So add on 3.
Onto what?
What you already have.
What's the answer? What that do you add it on y coordinate,
Yes.
not the x?
No.
Okay.
That would be if it was in the bracket next to the x. It would affect the x's.
Okay.
So y coordinates, times them by 2, then change the sign, then add 3.
Yeah. That's a long question.
I think it's a trick question.
Why?
Find the x coordinate.
Pardon?
Find the x coordinate. What was the x coordinate for tan, for the original thing? Tan 2x equals root 2?
I don't know. Do I have to work it out?
Yeah, so I think you did it already.
It stays the same, doesn't it? Because that's all the transformations in the y.
Correct. And so that's the trick. It actually doesn't affect the x in any way.
So if tan 2x equals root 2, then what was the range?
So x equals to root 2. Well, we know it's going to be this second one here. So it won't be the first one. It'll be the second one.
Second what?
The second turning point.
The minimum.
Yeah.
Then we just work out the minimum.
Yeah. So you worked out the minimum when it's y equals the f of 2x. What is actually this minimum? Coordinate this minimum?
4.7, something like that. 2.048.
So I think that's it. Attempts to find the first solution. Hang on. What did it ask us for? Use your hands to find the x coordinate of the minimum point on the curve with this equation. Yeah. So
it might be 0.47. I don't know which one's which. It's either 2.048 or 0.47.
X equals 0.478?
Yeah.
Yeah.
Yeah, because one of them's a maximum, one's a minimum. I just don't know which one's which.
Okay. So that's it.
Yeah.
And so it's kind of a trick question. That only affects the y direction.
Wow, sneaky of them.
Any questions there? Okay. Where were we? That was 15. Let's take a look at 14, see if it's worth doing. Integration, your favorite, using the trapezium rule.
I like integration when they give me everything, not when they leave something out.
Do you know how to use trapezium rule?
Yeah.
Is this one worth doing?
Yeah, it's quite easy to be fair. I don't know how to do it.
Shows exactly right. Okay. Let's go with 13.
Did you proof? Is there any proofs in this paper?
Why would you neck me like that?
Because I can't do it either, so I'd rather.
Proofs. Where?
Oh my god, is this paper where it's got like the table of proof?
Seems to be finding the word proof, but not prove that.
We can do that.
Is that
I think we've done it.
We did this one?
I feel like we have.
So perhaps then, so there's no proof. Will I look for in the other sample things for proof?
Sure.
Okay.
There was one paper where it was like a table of proof. I got it in the book. Hang on. It was grim. It basically meant just do like 4 different proofs. Hang on, I think I've got it. Oh, that's horrible. I really hope I never get that. Oh, here it is. It was like that. Can you see that?
1 sec.
It was like that.
Uh,
First Y, and then the first box was done for you, and then you had to, like, so one of the examples was when a real value of x is substituted into x squared minus 6x plus 10, the result is positive. Then you've got to set, like, tick which box it is, so either always true, sometimes true, or never true. And then you've got to give a reason why. It's basically the proof, and you have to do that like 3 times for 3 different proofs. Hate that. Hope it never comes up.
so if it's sometimes true, you could just show like proof by contradiction. So one time when it's true, one time when it's false. So that can be an easy way of doing that. So that's
Never true is a counterexample, isn't it? Or is it?
never true.
Oh,
No.
Sometimes true is a count. No. Sometimes true, you can just do a counterexample and then just one word work. So 1 over p11 minus 2p is the same as...
I believe it would have to be something over p plus something else over the other. Basically, they got a common denominator by multiplying the two together.
Oh yeah, so 1 over p11 minus 2p is the same as a over p plus b over 11 minus 2p. So 1 equals a11 minus 2p plus bp. Right, I can do that then. So then after that, what's the question?
Okay.
Well, actually, I don't know if I can do that.
Okay. A sec.
When p equals 0.
So p equals 0.
1 equals 11. A equals 1 over 11. And then you put that back in, so 1 equals 1 over 11. 11 minus 2. If x is 0 again, or should I just do 1? If x is 1, so 11 plus b. So 1 equals 1 over 11 times 9. 1 over 11 times 9, which is 9 over 11, plus b equals 1 minus that. Not very nice numbers, but whatever. 2 over 11, b equals 2 over 11. So 9 over 11p plus 2 over, oh god, 11 minus 2p. Is that right? That's really weird.
Did you say b was 2 over 11?
Yeah.
Is that what you got?
Yeah.
So
Wait, no. Oh yeah. Why did I put that then? Yeah, that's what I got.
so this is specimen 2. Sorry, sample 2. So they just wrote it in this weird way. 1 over 11, 2 over 11. Sure. Okay.
Amateurs. Determine the time taken years population of meerkats to one peas in 1,000. I can't even see. My battery's gonna die and I can't go. 15 minutes, that's enough time. I'm dying 15 minutes. Population of meerkats is being studied. The population is that. What? Oh god, is this a different question? Or is it part of the same? Oh, it's part of the same question. So I'm guessing we have to do like some implicit differentiation thing, type of thing.
Kinda.
1 over 22 p 11 minus 2p. Where p in thousands is the population of meerkats and t the time measured. Where is t? T is not even in the equation.
Nope.
Oh, so t equals the integral of that.
Okay.
Given that there were 1,000 meerkats, for a p in 1,000, so p equals 1, and the population ones, we're going to determine the time taken for this population of meerkats. So if p is in 1,000 and there's 1,000 meerkats, that means p is 1. Oh wait, no. Yeah, wait. No, it's 1,000, wouldn't it?
Okay.
No, it'd be 1 because p is, it says there that the range is 0 to less than 5.5. P equals 1. So if we put 1 to that equation, we get like the rate at which.
So you need t, basically.
Yeah, do you have to integrate that?
Yep.
I don't know how to integrate that.
Times both sides by 22.
Okay.
Or, tell you what, times both sides by dt. Don't know if this is the easiest way to do it.
Okay, 1 over 22p 11 minus 2p dt.
Yeah, what's next?
Get all the p's into the same side.
Yeah.
So divide by p 11 minus 2p.
Yeah.
Equals 1 over 22 dt.
Yeah. And then?
Well, you got me, I don't know.
Integrate both sides.
Where'd your dp go? How'd you get 1 over p 11 minus 2p?
I divided both sides by p 11 minus 2p. That's 1
Where's the one?
dp.
Yeah. Yeah, I'm gonna stop writing that now. So 1 over p 11 minus 2p dp. So integrate both sides. So 1 over p minus, that's just ln p 11 minus 2p in modulus, I think. I don't know, it's modulus, but whatever. And then integrate 1 over 22. Oh, do you have to do that bloody, what's that called? When p is times by 11 minus 2p. What's it called?
Reverse chain rule.
Oh, is that a thing?
So 11. So if I expand it, I would get that.
Yeah, I'll expand, I think. 11p minus 2p squared. You can't separate it when it's two different things on the bottom, can you?
No.
Do that.
What is the derivative of this?
The derivative 1 over 11p. Oh, derivative of just the 11p minus 2p squared.
Yeah.
11 minus 4p.
And so is this times 1 over 11 minus 4p?
What? I have to do.
We'll see. And what's on the right side?
Minus 22. No, hang on. It's just a constant, so it's just 1 over 22x. Or no, t.
And last thing when you integrate?
Plus c.
Plus c. I get the feeling that this part is wrong because we have a p in there. That might have to be some kind of special integration.
Like a or something.
So the derivative of... Oh, they put a 22 over that. Oh, we'll work out same thing. Oh, hang on. Part A. What was part A?
Don't know.
Part A was 1 over p 11 minus 2p.
Yeah.
And we have 1 over p 11 minus 2p. And so that we can just put that into partial fractions. And so we can be definitely certain of it. So our partial fractions were that.
1 over 11 p plus 2 over 11 minus 11.
And so
11 minus 2p.
And so just integrate these two.
So ln 11p modulus plus 2. Wait, now. Do you have to like a product or something?
That's if there was a second p on the bottom. I would just write it as 2 over 11.
2 over 11 ln 11 minus 2p. My battery's about to run out. What have I told you? Is it here? No, it's not.
Don't forget reverse chain rule for both of them.
I don't know what that means.
What's the derivative of 11p?
11.
And so, coefficient?
11.
You times you divide by 11 because it's integrating. So same thing for this one?
So, minus 2 times. No, so, 2 over 11. Minus 2 times 2 over 11.
Yeah. And so that's 1 over 11 ln 11p plus 2 over 11 ln, minus 4 over 11 ln 11 minus 2p. Any questions with that bit?
No.
So you have to divide by the derivative. And so that is equal to
1 over 22.
t plus c. And what's next?
Substitute 1,000 for p.
Yeah.
Divide that by. Then you're gonna have. You still have 2 unknowns.
What is t?
Oh, 0.
Yep.
To find out c. Then you do the equation again. But put 2,000 in when you've got c. And rearrange to find t.
Yeah. Actually, you don't need to. That's just 0, isn't it?
Yeah.
So it'll just be that will be equal to C.
Yeah.
No rearranging necessary.
No, then you find out C, and then you put it in again as C, and then put 2000 in for P.
So C is minus 2 ln 9. And then you put what for?
2000, because it's when the population doubles.
Okay.
How many marks is that? Oh wait, no, not 2000. It's 2, not 2000. So the other one would be 1.
No. We're trying to find time. So yeah, it's when the population is 2000.
Yeah, but it's in thousands already, and P is less than 5.5.
So there were 1000 in the beginning.
Yeah, but it's P is in thousands already. And then over at the top it says...
So it should have started with 1, and then it becomes 2. Oh, okay. Yeah. There you go.
And then rearrange for 2.
So it's, yeah.
I've got too many words in these maths papers.
That is.
It's minus 4 equals 1 over 22 t plus, what was it, 2 ln 9?
Minus 2 ln 9. And that's just a linear equation, so that can go into the solver. If you dare.
I don't have one.
You do. Hang on. Graphical. Change your life. Option, is it? Even run matrix?
Yeah.
Option calc F4.
So, that's what I said last week, but then didn't do anything.
Solve n. It does plenty.
Oh, it's solve for n.
Yeah, solve n.
Damn. That would be nice to know. Oh, I've lost it. Option.
Calc.
Oh, solve for n. That's mental. Are you doing it, am I? Oh, you're doing it. Good.
Well, I'm trying, but I don't know how ln works on your calculator. There's no bracket.
No, you don't need a bracket.
So how does it know to...
Ln 4.
10, so I'm just going to do 7. And then shift equals...
Oh, you're trying to do the modulus thing?
No, I just kind of did that little bit myself just to... X minus 2.
7. What does it equal?
87.3. See, I don't know how to put it in properly. I think 1.89 years. So I can do it in the other calculator, but I don't. In your one, I don't know how ln works. So you see how, like, do I just take away the bracket? So you see ln 22.
Yeah.
So I don't know, like, when does it...
Maybe put the bracket around the ln and the 22 instead of just the 22.
So that would definitely work, I think. Let me press this one. So that's the same. So bracket along 22.
Yeah. This laptop is going to
7 equals a half. And I think that should be good. I don't know. We'll work on that one. We're putting in the right values anyway.
Oh, it just died.
Oh, all right. Well, good luck with your exam, if you can hear me. Hello, Juliet. Hello, Lotso.
Fell asleep.
Are you thinking you're in bed or something? If you fall asleep, you must be dead in the head. I was talking to this lady 5 minutes, but she finished. It looked like she's still there because her battery is dead, and so it's still there. But she's not even
She's
there.
still there?